Hello UBC WasteNauts. In this video we're going to cover the use of 3D printer and the safety procedures behind it. While using a 3D printer, the only safety equipment you're going to need is a lab coat, and make sure to not touch the nozzle while the 3D printer is operating. Once you have designed your STL file, you're going to change it into a G-code, which I'm going to cover at the end of this video, and then upload it into a SD card. I've already uploaded an image STL file into the STL card, so you just plug it in and turn on the 3D printer. Now I recommend you to plug your micro SD card before you turn on the printer, because if you do that in the other direction, the printer might not read the SD card. After you have turned it on, click on there, and then you will see a print from SD card option, and then you're gonna see the code which I have uploaded, which is the screw G code. If you're gonna print more than one design, you might have to press the refresh button to make sure that the appropriate G code is there. Once you have, make sure you have selected the right G code, press on it, and now the printer will heat the bed. After heating the bed, it will heat up the nozzle. As you can see, the bed will heat up to 50 degrees, and it's currently at 21 degrees. And extruder right now is at 16 degrees, and after you finish heating the bed, it will start heating to 200 degrees. Here will show how much of your model has been printed. So far it's 0% because it hasn't started printing, and now we'll wait. Now that the printer was fully heated, it's now readjusting the axis so that it starts printing, and you don't have to worry about that part, because the printer can automatically readjust the axis of the hotbed, which will go back to the origin. And one more thing to note out is the filament that's going to be used is a high quality filament. And what makes a filament high quality is that if it is exposed to a moisture, like open air for a long time, it won't snap. And there are some low quality filament that might snap inside the Teflon too, which makes it much harder to clean. But for this filament that's going to be used, it's high quality, so there's no issues about that. You can see the printer is almost adjusted its hotbed, and it will start printing in a few seconds. And you can see right now it's almost starting, and according to and you can see like the coordinates of the extruder as it is moving. And now we're gonna wait for 17 minutes, and then the model will be done. 17 minutes ahead, the design has been printed, which is the screw. And after the printing has been done, you might want to leave it a few seconds such that the last part that's been printed solidifies. When you remove the model, it might be difficult to do it in the original position, so you might want to move the hotbed down in the z-axis. To do that, you click on here, go to prepare, click to move axis, click on how much you want to move it, select the z-axis and move it down a bit. Also, another thing to keep in mind is that if you want to remove the model from the hotbed very easily, you might want to increase the temperature difference. So right now the hotbed is at 36 degrees, so you might want to heat it up like up to 50 degrees where it was originally operating at, so that the plastic that was at the hotbed softens and becomes much easier to remove. So you go to click here, go to control, temperature, hotbed, which is now currently targeted at 0 degrees. You dial it up to around 50 degrees, you have to be accurate, and now it slowly heats up. Using a scraper, the model can be easily removed from the hotbed, and this is how it looks like. Now, for the larger your model is, the more accurate the printer will be, since we are using a 0.4 nozzle. If you made the model is too small, there might be some inaccuracies. Once you have printed your model and you have removed it from the hotbed, now you have the second procedure, which is just involves cooling down the printer. So you go to prepare, move down to the end, click on cool down, and the target is then changed to 0 degrees on both for the nozzle and the hotbed. And once the temperature cool down enough, especially the hotbed has to go like around room temperature, like or close to the nozzle temperature, then you can turn off the 3D printer and unplug it.
The software that I'm using to convert an STL file into a G-code is Ultimate Calculator, which is a software recommended to be used by the Creality Interface printer, but you're not restricted to using that software. Once you have created your design in Fusion 360 or SolidWorks, you can export the STL file and then import in this file in this software. So once you click on the image, you have certain features that you can adjust. One of them is positioning the model. By default, the printer will print the model like through the center of the hotbed, and the hotbed is represented by the bit squares. You can either move it in the X, Y, Z axis using the arrows or by entering numbers here. This feature will be useful in case model is too big to be printed if you start printing it from the center. Another option would be scaling the design itself. Maybe if you want to test the effect of having different scales of the same design on the accuracy of the 3D printer. And it can be uniform or not. If you want uniform, just unclick this option. Another feature is readjusting the design itself. We want to make sure that it starts printing from the base of the design in case it wasn't oriented correctly before you export it from the SolidWorks or Fusion 360. You can do that here by moving it. Once you have correctly oriented your design and scaling it, you can see its final dimensions and represented by length, width, and height, and it's equals in millimeters. Another thing to make sure is that you set your software to a Creality Ender 5 printer with a generic PLA and a 0.4 millimeter nozzle. This will affect the rate that the design is printed. Once everything is adjusted, you can now slice the image, and based on this dimension, it's going to take it 28 minutes. It's going to be 1 grams. You can go to preview and see how many slices are there. In this case, there are 238 slices, and for each slice, you can see how it's going to be printed. The monitor part is if you're going to connect your laptop to the 3D printer, but we're going to be using the SD card, so not required. So once you have sliced your image, you can now export it as G-code, which is done by going to File, Export, and save it anywhere you want. Just make sure to use simple names like screw 89. Make sure it's only lowercase letters, numbers, no uppercase letters, spaces, or special characters. And make sure to click on G code and save. Now you'll be able to move that file into the SD card and print.